Kinda. It's one more step. All right, guys, if y'all look, let's go back and let's do number 4 because I know we skipped it yesterday. All right, so let's look at number 4. So Ni plus Pb NO3 2. Now, just looking at this, you see no products. What type of reaction is this? This is single replacement. How can you tell that it is single replacement? Okay, you have one single element, and then you have a compound. Now, again, just like we did yesterday, let's go in and label what we know.
I was looking at the sheet last night, and I kind of forgot. How do you identify double reaction?
Hold that thought. We're going to do one. Is that okay? Okay. Yes, ma'am. Come up here, please. All right, so nickel. What kind of element is it? Metal. Very good. Metals like to be what kind of ions? Cations. Very good. All right. We know lead, since it's written first, what is always written first? Cations. Very good. And nitrate is written second, so it's an anion. What else do we know about lead? What kind of element is it? It's a metal. All right. Which two match? Nickel and lead. So since they match, they're going to want to swap places. However, before you swap them, what must you look at for single replacement? You got to look at this. And I will tell you, it will work. But how would you know if you were looking at this will work? If nickel is above lead. Very, very good. So nickel is going to have to be above lead for it to work. And in this case, it is above it. So Ni is going to be above Pb. So they're just going to swap places. So what's going to happen to poor old Pb? It's going to be kicked up by itself. Will it become Pb2? No. Very good. Why not? It's not a diatomic. Charles, yes, sir? Okay. All right. Now, so here's the issue. Nickel is now going to be with who? Nitrate. Is that a new compound? Juan, what do you do with new compounds? How many times have I asked that question? And you still see why I ask it every single time? Thought you weren't asleep. Okay. All right, but here's the issue. The problem here is nickel is a transition metal. So what's its charge? I will tell you what it's going to be. Okay? If it's not obvious, I'll tell you. So it's in this case, let's just call it nickel 2. Let's just say for this case, we'll call it nickel 2. Okay? So nickel is a 2+. Nickel is now with nitrate. What is nitrate's charge? NO3 negative. So from this point, can you go? What do you do here? Crisscross. So you get NiNO3 2. All right? Very good. Very good. Got to put it in parentheses because if you left it like that, 32 just looks ridiculous. Yes, ma'am. It is, but you've got to remember that you only check your charges when it's with a compound. Okay? She brought up a good point. I'm so glad she said it. What she said, please listen, this is very important because people are going to do this if you don't pay attention. Which lead is this and how do you know? It's lead 2. How do you know it's lead 2? Remember, you reverse crisscross, you pull that back, you pull this back. Do you put lead 2+? You will never write an element with a charge. Never. Okay? The only time you'll do charges is when you crisscross them. There will never be a plus or minus in any formula that you ever do. All right? For now. You hear me? For now. Next year, totally different story. AP is a little different. Okay? I'm not talking about that. That's why I just said for now. Just go with that for right now. All right, so now basically ignore it. It's already going to show up balanced because it was one nickel, one lead, 2 nitrates, and 2 nitrates. So it was balanced as is. What? Okay.
So it's just 1, 1.
1, 1, 1, 1. There's 4 ones.
What type of reaction is it?
You tell me. You have one element swapping places with a compound.
Single.
Very good. Single replacement. All right, so let's do 6. I finished 5 yesterday, correct? Awesome. That's besides the point. So Na2SO4 plus ZnBr. All right, Na2SO4 ZnBr. Is this a combustion reaction? I don't see any oxygen. Is this a decomposition? Nope. Decomposition is one thing breaking apart, right? Is this synthesis? Nope, that's taking 2 things and making one. We're not doing that. Is this an acid base? Very good. Make sure you recognize that it's not an acid base. Is it a single replacement? Do you see anything single up there? So it's automatically going to be a double. Do you see how the process, sometimes it's easier to say what is it not than what is it? Is it Br2? Thank you. All right, so let's label what we know. Since Na is written first, it's what kind of ion? Cation. Sulfate second, so it's an anion. Zinc is first, so it's a cation. Br is an anion. Also, we know that Na is in group 1, so it's a metal or a non-metal. It's a metal. Sulfate's really not anything. It's a polyatomic. We don't really identify that. Zinc we definitely know is a metal, and then Br is a non-metal. All right. So this time we actually have more than one that match. We have cations and anions that match. Does it matter which ones you swap? Nope, it's going to be the exact same thing no matter what you do. Me, I'll just swap the first ones. Here's the question that I have been getting all day. Let me just go ahead and answer it. I'm going to answer it in a long, kind of abbreviated way. Na is now going to be with who? All right. Zn is now going to be with who? SO4. So here's my question. I have Na and Br together. I have Zn and SO4. Does it matter in which order I write those compounds? Does that make sense what I'm saying? Okay. I'm swapping them, but does it matter in which order I write them? Here's my encouragement. Whatever is written first on the left, write it first on the right. Does that make sense? Whatever's written. Does it matter? No. It's just an encouragement. It's the way I do it. It's just a good strategic way to always approach it. Whatever's written first on the left, write it first on the right. So we're going to start with Na. Na is now with who again? Is that a brand new compound? What do? Shake your chalk. Because we swapped Na and Zn. You with me? Okay. And here's another thing. If you think about it, why would Na not be with Zn? Can you put 2 cations together? No, you can't do that, okay? So that's another reason why I label them. You can't put 2 things that are the same together. All right, so Na is in group 1, so it's +1. Br is in group what? So it's a... Very good, guys. There's 2 things that's going to destroy you in this chapter. Number 1 is not knowing your polyatomics. There's 4 things. Number 1, polyatomics and their charges. 2, your diatomics. 3, checking your charges. And 4, being able to know the transition metals, being able to reverse crisscross. Those are your 4 major flaws that's going to kill you. 1 again, I forgot what they were. Diatomics is one of them. Checking your charges, polyatomics, and reverse crisscross. Those are the 4 major things. All right, so we have NABR. All right, who is Zn now with? This is very important. Please listen. This is what's going to get some other people. So if you want to add this to the list. Does it matter the order in which you put Zn and SO4 together? Yes. Drastically matters. If you put SO4 first, is it right? What's always written first in a compound? And notice what we've already done. We've already labeled it. We've already labeled it. So you should know that Zn should come first. That's very important. The cation is always first. So if you want to label that or write that down, cation always first always first. And this is another one. Zinc. What is its charge always? Okay. Kara, what is sulfate's charge? To what? Very good. So what's going to happen to my charges right here? They're going to cancel, so you get ZnSO4. Last question. Is it balanced? Balance it. This one's a real easy one to balance. Real easy to balance. You just need one coefficient. Where does it go? And what is it? Very good. Very, very easy. So, this is where it kind of maybe be a little different. If you were doing this on your own, and watch what if you had written ZnSO4 first? Would that change what your balance would look like? But guess what? I'm smart enough that when I'm grading this, I can look at it and tell what you have done. So the way that I have it written, it's 1, 1, 2, 1. But if you invert these, what would it then be? 1, 1, 1, 2, right? I can figure that out. I know what you're doing. So it doesn't matter. I can figure that part out. As long as your NABR is right, and as long as your ZnSO4 is right, you're golden. All right, 7 is kind of tricky. It's kind of a pain in the butt. I would never expect you to do this on the test. Good news. That's why I said give it a whirl. I would not expect you to do this. There's only one thing that I would expect you to do with this. After we're finished, I'll tell you what it is. H2 plus O2 plus SO3. All right, so let's kind of play with it for just a second. What do you think H2 and O2 could come together to make? So this and this, I'm thinking it can make water. That make sense? Well, you're wrong. Okay. So this and this can make water. All right. This is the answer, and I want you to stare at it long enough to see if it just kind of comes into your mind. So we're going to take the water, and we're going to mix it with the SO3. See if you can figure out, just kind of stare at it and see if it makes sense. Just look at it.
H2SO4.
All right. So notice, we have H2, right? We have H2. What did I do? All I did was add an S. Well, here's my S. Here's my S. Well, I had an O, and I had 3 O's, so then what do I have? 4 O's. Now, again, that's a very, very, very basic, minimal, easy way to explain it. That is right. Okay? That is right. This is what I would expect you to do. I would show you this and say, what type of reaction? Is that decomposition? Is it acid-base? Is it double replacement? It's synthesis. You're taking a bunch of little pieces, and what are you doing with all those pieces? You're putting them together. So that you're taking actually ABC, A plus B plus C, and you're making ABC. That makes sense a little bit, kind of? Yes, sir. That's all I would expect you to get out of this. I would show you the whole thing and say what type. It is not balanced. You're correct. It is not balanced. Balance is 2, 1, 1, 1, 2. I think. Nope. 2, 1.
No, it needs to be alternate.
I balanced it earlier. I forgot what it was.
2, 1, 2.
That's right.
So you'll show us all of that, and then ask us what it is?
Exactly. That's what I would do. I would never make you do the products on this one. Okay. All right, and the last one, all you had to do was balance and identify. What type is number 8?
Single replacement.
Very good. Single replacement. Very, very good. All right, if you will flip over on the back and look at the left side, please. All right. You had a week off.
I didn't get any sleep.
I didn't sleep at all. I mean, I slept like 3 hours a night.
That's your fault.
Honestly, you went to a party? Oh, it was a birthday party? He just said he went to something about the. Wait, what party did you go to? Answer me. He didn't want to go into the description of the party he went to. I really just don't know what he said.
I don't either. Okay. All right, so let's look at this one. This is number one. This is number one. Looking at this, is this synthesis?
I don't know.
Is it combustion? Is it single replacement? No. Is it decomposition? So basically, it leaves it as two things. What does it look like, just a very generic version? It looks double, but is it? No, it's an acid base. Very good. It's an acid base. So let's talk about how you know. A base ends with what? Very good. A base ends in OH. What does an acid start with? Very good. Acid starts with H. All right. Now, this is something I am requiring you to know. All acid-base reactions produce a salt and water. So we know that at a minimum, we're at least going to have a what as a product? Not salt water, but salt and a water, which is HOH. All acid-base reactions, I encourage you to write HOH. It makes it a lot easier to balance. A lot easier. All right. We're going to treat this one just like we treated all the other ones before. Let's label what we know. Ca is written first, so it's a what? A cation. OH is written second, so it's an. H is written first. Even though it's not a metal, it's still first, so it's a what? A cation. And fluorine is written second, so it's an. All right. So we know this to be true. We know that what two things are going to swap? Ca and H. Very good. All right. What if we've already taken care of one of the compounds? Do you agree one of the compounds was already HOH? We've already done that one, so we're good there. Now what do we have left? What two things do we have to pair? Ca and F. Very good. Is that a new compound? Charles, what do you do with new compounds? Very good. Ca is in what group? 2, so it's a 2 plus. Fluorine is in 17, so it's 1 negative. So it's CaF2. Last question. What do you do with all reactions? Got to balance them. Make sense? Sure? I mean, stop me if it doesn't. I mean that. Okay. I mean, this is pretty much the extent of it. How do you balance it? 2, 1, 2, 1, 2. Any questions? All right. Let's do number 2. PB NO3 2 plus K2 CrO4. Now, I've given you a hint, but before I talk about the hint, tell you what, let me do it with the hint. What is the hint I tell you right above number 2? I tell you that it's lead 2. Could you have figured that out if you had not known, or I had given you that hint? How could you have known? Very good. So again, here, you just reverse crisscross this, you'll get a 2 plus, pull that back, you'll get a 1 minus. Everybody okay with that?
Do you always give it to us?
I haven't made up my mind yet on if I want to give it to you or not. I haven't made up my mind. All right. Well, let's label what we know is going to be true. First of all, let me take a step back. What type of reaction? Is this acid-base? Very good. It's not acid-base. It's double. All right. Let's label what we know. We know lead is first, so it's a cation, but it's also, since it's a cation and it's a metal. Nitrate is written second, so it's an anion. Potassium is first, so it's a cation, and it's also a metal. What is CrO4? You ready for that one, weren't you? Okay.
You win on the.
Congratulations.
You need to buzzer on this.
Never mind. All right. So now what we need to do is we need to do something. Am I going to put PB and K together? Why can I not put them together? They're both metals. You can't put two metals together. That doesn't make any sense. So we're gonna swap them, swap places with them. So PB is now gonna swap with K, and it's gonna be with chromate, and K is now gonna be with nitrate. Again, does it matter in which order you write them on the right side? What was the hint? Whatever's first on the left, first on the right. All right. I've given you the hint. Look right above number 2. What is our lead's charge? It is lead 2. So PB 2 plus. All right, Hamza, what's chromate's charge? You sure? Are you positive? Are you too positive? Or are you too negative?
I think it's positive.
No, it's negative 2. All right, it's 2 negative. Again, guys, get back in those polyatomics and start learning them again. You've got to know these. Good thing you didn't. All right, so that's the first one. What's the second one going to be? What 2 elements? Very good. Be very careful here. Which one, K or NO3, must be written first? Why K? Angelique, why K? Why is K written first? Yeah, but it's what kind of ion? Cations are always written when? Very good. So cations got to go first. So we have K plus. Why is it just a plus? Group 1, nitrate is NO3 negative. So it's just KNO3. Final question. What do you do with all reactions? Got to balance them. This one's pretty dadgone easy to balance as well. What do you need and where? Very good. A 2 on the KNO3. A 2 on KNO3.
So do 1, 1, 1, 2?
1, 1, 1, 2. Or if you were doing this on your own and you wrote KNO3 first and PBCrO4 second, it'd be 1, 1, 2, 1, which is fine. I'll figure that out. All right, any questions? All right, you guys do 3 through 7 on your own. See what you can come up with. No. All right, guys, I'm going to teach you how to do the next one, but I've got to teach you a few points while I do it, okay? Because I see some issues that not have come up. I've seen it once in this class, but I've also seen it in some other classes, so I do need to talk about it. So number 3, NaC2H3O2 plus H2SO4. All right, number 1, what type of reaction is this? How do you know it's double? You have 2 compounds. Why is it not an acid base? There's no H. All right. Now, here's the deal. We have Na, which is the what? It's the cation. What is this big, ugly C2H3O2 thing? That is acetate. You've got to recognize polyatomics. So it's second, so it's what? An anion. All right. H2 is what? The cat. SO4 is the anion. This is the teaching point. This is wrong. Don't do this. This is wrong. We all agree that H is going to swap with Na, correct? So H is now going to be with who? Acetate. Here's, again, don't do this. Because H has a subscript of 2, am I going to transfer it over? Am I going to say, all right, well, there's a 2 there, so it's got to be H2C2H3O2. Do you transfer subscripts? No. Think about this. Where did this 2 come from? Who does it really belong to? It really belongs to sulfate. It doesn't belong to that H. You can't take it with it. It's not his. You have to leave it alone. You have to leave it where it is. Because once you have a new compound, what must you always do? Check your charges. So if you would have done that, you would have realized. Notice, look, this is H plus. What is acetate's charge? C2H3O2. What would happen to those charges? So where in the world would that 2 have come from? You wouldn't have it. So number 1, don't transfer your subscripts. Number 2, this is also wrong. Please, since you see, oh, well, there's got a 2 right there, I'm just going to plug in a coefficient. Again, that's wrong. You write your formulas as you need them based on their charges and then balance at the very end. It may be that case, but don't do it until the very end. Okay? All right, so now, we know that this is not correct, so let's correct it. All right, so Na is now going to be with who? SO4. Is that a new compound? What do you do? All right, Na's in group 1, so it's a what? It's a +1. What is sulfate's charge? All right, so I have Na plus, SO4, 2 negative. So what's my formula? Na2SO4. Everybody okay with that? All right, now because of space, I'm just going to go below it. H is now with acetate. Well, we know that H is a +1, acetate is a -1. So we have HC2H3O2. Now your formulas are done. They're correct. Is it balanced? Now is when you can begin to balance it. How do I balance this one? I need a 2 here. Sorry, that didn't show up. I need a 2 here. And then a 2 here. So a 2 in front of the sodium acetate and a 2 in front of the acetic acid. Okay. So any questions there? That's it. Do what?
2, 1, 1.
2, 1, 1, 2. Or whichever order you wrote them in. Does that make sense? You know, I wrote the bottom one because of space. So, but you can put either one first. It doesn't matter. All right, let's look at the next one. CuOH2 plus H3. All right. What kind is this, or what type? Very good. This is an acid base. All acid-base reactions produce a salt and a. Go ahead, as soon as you recognize that it's an acid base, go ahead and slap your HOH on there. Okay, put it at the end. Just slap it down. I just like to put it at the end, just because I have it. There's no real reason. I base that of habit. All right. But again, that comes into play. Does it matter which order you put the products in? Sure doesn't. So you can do whatever you want. So we know that H and OH are together. So what about Cu? Who is it with? It is with phosphate. Any questions here? All right, so here's the deal. Is that a new compound? It is? What do you do? I gave you a hint. What is copper? Very good. Copper is a 2+. This is a tricky one. What is phosphate? What is it? Very good. 3 negative. All right. So when you crisscross here, this is going to be kind of a big one. So you have Cu what? 3 PO4 2. Did I do that right? That's right, isn't it? No, that's right, isn't it? Is it?
You trying to say it's not?
You tell me, is that right?
No, you need parentheses around the PO4.
Thank you.
Get it, Laura?
I'm doing that on purpose.
I was wondering.
So that is now correct. From this point, we need to be able to balance it. All right. I will. All right. So how many Cu's on the left? How many Cu's on the right? I need a 3 on this side, right? All right. I'm going to go to phosphates next because I saved my H's and O's for last. All right. How many phosphates do I have on the left? Phosphate is PO4. That's one thing. Does that make sense? Okay. How many phosphates do we have on the right? This is one whole thing, and that 2 goes to that one whole thing. Yep, so I need a 2 right here. Now, I'm going to look at H's next. I have 2 times 3 is, but over here, I only have how many? Remember, this is H, and that is OH. Now, notice, look, because OH is also right here. So I have 3 there, and 2 there. So I've got 6 hydroxides and 6 hydrogens. So really, all I need is a 6 right there, and it's done. 3216 or 3261, depending on how you wrote your products. Yes, sir.
At a more advanced level, can you use balancing to check if that's indeed the product? Is that how they?
I mean, this is the product.
If you were theorizing, like I read something about they have in chemical engineering, they theorize what things would happen.
Yes. Theoretical chemistry, they basically try to, if I have this and this and I put them together, what would I make? In theory, yes, this is theoretical chemistry. Yeah, but basically, if you did this lab, you would get that product. You would get copper phosphate. You'd have to run it through an analysis, but you could figure it out based on UV absorbance, spectroscopy, mass spectroscopy, conductivity. Basically, taking a compound